Tinkle, man. You wanna go play? Come on. This way. You better go run. You better go run. Where you going? Running like crazy. Come here. You better go run. You gonna go? You gonna go? Well, now that we've gotten the weather to cooperate, I can show you exactly what we've accomplished here. That tree looks a whole lot different than it did before. So, picture it upright, it'll actually look pretty good. This top section here, in future seasons we're gonna trim that back and just give it a little bit better shape, but it'll do for now. And in our next little clip, we're gonna be dealing with the lean and this nasty fungal infection. Stay tuned. The base here all cleaned up, removed all the weeds, exposed some more of the root flare so we can see just how far down this damage goes. Plus, most trees are planted too deep anyway. You need to have that root flare exposed, which would be this. The part where the trunk starts to open up and look like it's grabbing the earth. It's where the top of the roots begin. Now, first step. Hydrogen peroxide, about 3% dilution. You can go a little bit stronger, but if you can see here, this plant is actually recovering just a little bit. It's starting to callus new growth over the wounded area. But we're gonna start with this just to help it along. Spray it all over the damaged portion. And I don't know if you can hear it on the mic here, but it is just a hissing and sizzling as it's doing its work. Now, peroxide's great because it kills a lot of things. It's gonna do its job and then decompose into carbon dioxide and water, and basically it's non-persistent. It does what it does and then goes away. And then we're gonna assist with a SOS scrubber. Just scrub all this down. And now I'm gonna go off camera a little bit so I can get some focused energy into this, and I'll show you the results. All right, now that we can see what we're working with, that's a significant change there. You can actually see the underlying heartwood. It's got that reddish hue, and I had to use a little bit more aggressive than the SOS scrubber. I used one of these guys, steel scrubbers. I would not go any harsher than that. You could use a steel brush, but you'd have to be careful because you don't want to damage the live vein here. Now I have roughed up the live vein a little bit there, and that in small amounts will actually stimulate growth rather than do continual damage. So if you get it like right here where you just get a little bit of green showing, and just a little bit, that's more than enough. And we peroxided it again. Actually, peroxide, kind of scrub and peroxide, scrub and spray. And now we're gonna use our other mix here, which is a combination of neem oil and potassium bicarbonate, which is an antifungal. And now, don't expect any fancy reactions from it, like the peroxide. It won't foam or nothing, it's just gonna sit here, we're gonna spray it down and allow it to soak in. And it's definitely changed the color and pattern of the wood, but we can see that is a nice strong live vein. This tree is fighting to survive, and we are gonna give it some assistance. Now that, we're gonna allow that to soak in and do its job for a little bit. And then we're gonna move on to our final protective coat, which is a combination of, it's basically a pitch resin that I make, and we'll do a video on how to make that stuff later, but it's multi-purpose, antifungal, waterproof, and you can dissolve it down with alcohol or oil to make it much more workable than with the crystallized resin that you normally have to deal with. And if you ever get it enclosed, that's a good way to get it out too. But not the topic of this video. We're just going to be doing a little bit of a cleaning and maintenance on this, and then we're going to try to ever so gently get her to start moving in the right direction as far as the lean here. But that is going to be a more long-term, taking a little bit at a time kind of effort. And what we have for that is right here, good old T-posts pounded into the ground, and we're going to take a strap from the post to about that midsection there where the trunk splits into three. wrap it around that and gently start ratcheting it up here. We're only going to go probably about an inch today, and every month or so we're going to cinch it in just a little bit more, just to gently put a little pressure, because at this stage, with it being damaged like this, we could risk damaging it worse, and we don't want to do that. So correcting that lean is going to be just a patience game. Okay, we've given a chance for the neem oil to settle in, and it's kind of dry to the touch now, dry on the surface, and we are going to move on to our resin treatment for the final protective coat, just to help suffocate the fungus that's still there and prevent reinfection. Now this wonderful stuff right here, too bad you can't smell it. It smells fantastic. It is a combination spruce and pine resin that have been partially dissolved in alcohol to make them workable. You just need a brush, nondescript, nothing fancy. We're just gonna dip her in here. Let's get a little bit. Now this is the nasty stuff. You get it on your clothes, you're gonna need alcohol and or vegetable oil, oddly enough. Will dissolve it off of you, so you can actually not have to throw your clothes away. Then you just paint it on like this. It's okay to get it on the live vein. It will not hurt the plant. The alcohol will just quickly vaporize out, especially since we got some wind today, and this will harden into a protective coat. It will not prevent the live vein from still closing this wound. It will dry and flake away over time. We may have to reapply, but I'll do a coat now and show you what that looks like when it's done. Well, the wind has picked up, which is good for the resin, but kind of lousy for filming in the microphone. So, well, the show must go on. Bear with me. All right, so we have a good solid coat of I guess this would be called a pitch glue, but it is a dissolved resin. And as you can see, because this down here had some cracking, and the live vein was okay, but the bark had shown previous damage, so I just coated it anyway. Took the brush, made sure it got in every gap, and obviously we have a little drip spray here, or a little over drip here. Not a problem. I sealed up the live vein even on there. All of this, I don't want to touch it right now because it is ridiculously sticky, but it was getting hard to work. Like I had started at the top and went down to the bottom, and then I went back to the top, and the top stuff in about 10 minutes was already difficult to work. It was a lot thicker. The alcohol is vaporizing out thanks to the wind and the sun. And this stuff by probably a day or two will be hardened and crystallized, and it kind of looks already like I varnished it, and it will kind of harden up like a natural epoxy, which when you consider what the spruce trees I got it from use that resin for, well, they secrete it specifically at wound sites. It's meant to prevent bugs from getting in, and it's meant to prevent fungal infections. It has natural antimicrobial in general. There's even studies that suggest it has antiviral properties, but definitely antibacterial and antifungal in the botanical sense. I mean, hell, ancient cultures used to use it as a wound sealant for, well, humans. So, I will call this section pretty well done. It does kind of look like a nice red varnish there. And then we're gonna go on to the last bit of this mission and try to straighten this tree up a little bit. And what I'm doing with that is our T-post here. I got a ratchet strap. Now this ratchet strap had gotten damaged in a prior project, so I cut the damaged end off, and that is now gonna be a nice bright shiny orange strap, so that whenever the lawn gets mowed here, nobody runs into this, because even with the white top, these T-posts can sometimes be difficult to see. So I'll have that all set up with a turnbuckle, and I'll show you how we do it. Okay, so it looks like a clustered mess, but here's our basic setup. This right here is one of the strongest parts of the tree, and it's the highest I want to grab while still having a main leverage point on the trunk. So I can very easily affect the whole size of the whole shape of the trunk, but I could also break it here, so this is where we're going to be careful. I tightened up the trailing end and just draped it over this branch so it's out of my way. We got some tension here, and now we're going to start the trickiest part of the process, which is going to be this tightening and cinching down. And I only wanted to film this so that I could show you exactly what I mean by how subtle we're going to be. We're only going to be moving this guy. There's about ½ an inch there. And that's it. That's as far as I'm messing with it today. And now I'm going to put up my turnbuckle right here and lock it in place right here with some wire. our leading strap there is going to go around the other end and go out to here. Same concept, it's going to wrap through and grab onto this. And I'm just going to tighten it. And then I'm going to release the ratchet strap. And we're going to probably repeat this process. And it's off by about 25, almost 30 degrees. I want it to be standing upright right about here. So we have about a foot to go. Which means if I do an inch a month, in about a year, this will be upright. Which a year is kind of what I planned this for. And I will film when we're done. I will show you what it looks like. And I want to keep that out of the resin because the resin's still gooey. Now, yeah, it's starting to dry up pretty nicely now. Now, last thing about this, a year is a pretty darn good timeline for a deciduous tree about this size. Now, unlike conifers and evergreens, deciduous trees are rather vigorous in their growth. And this live vein right here, under optimal peak plant nutrition and photosynthetic efficiency, this plant will be able to add vascular tissue at almost a rate of ½ inch, depending on the species, up to an inch a year, which what we're looking to do is within a year to 2 years, close this. And it looks like it has a good, before it starts sealing off, even the widest portion down here, it's about 2 inches. So we got about 2 years. That said, in a year, if we get this thing nutritionally in its peak, we'll be able to close that significantly. Alright guys, we got our turnbuckle set in place, we got our wire here, and that's about the tension you want. And you see I tied a knot. I'm trying to keep the knot off of the actual bark tissue here because as this grows I don't want it to cut in. It probably won't. This has got some elasticity, but just not taking any chances on it. Now the idea is every month or so I just go and turn this turnbuckle a little bit and draw these in about a ½ inch, which will translate, ½ inch on both sides, will translate to about an inch of pull every time, and then when it gets down closed up, we'll redo the whole ratchet strap and start all over. Probably on the first of the month. Every month we'll do it for about a year and see where we're at. And now you guys probably thought we were done, weren't you? Yeah, not so much. We got more work to do down here. Now the question is, why did this fungal infection happen to the tree? Was it neglect? Was it poor genetics? A lot of studies are now saying that a lot of these infections, bacterial, fungal, even insect, are related to the nutrition of the tree. Because the tree actually has, all plants actually have, a very strong natural immune system that can fight off a lot of these infections. Kind of sounds a little bit like humans. And much like humans, when our nutrition is deprived or we have a deficiency, our immune system tends to be the first thing to go. So I mixed up a top dressing that's going to go in the soil, and we're going to give, basically throw the alphabet soup at this tree and see what it needs. So we have a pretty complete diet over here for him. Alright, now this is our mix that's going on the top dress. But first things first, yeah, these guys are going to get a free advertisement from me because I'm very fond of their products. We got BioLive. Now, I tend to ignore the nitrogen, phosphorus, potassium things on here. I'm more interested in what's in them, and this particular one has a lot of endomycorrhizal and ectomycorrhizal, and one particular organism I'm looking for is trichoderma. Trichoderma is a neat little bug. Now these are just, that's a fish meal variant, that's neem seed, which will help with fungal stuff. Green sand is minerals, a lot of marine-based minerals. We've got some magnesium sulfate here. Can't read that, but that is azomite, so rock dust, and a little bit of soil sulfur, because that is key. Soil sulfur and boron, well, it's a split open bag of borax, but boric acid, these two are key in boron's case for translocating sugars throughout the plant and makes it more efficient. It also allows the calcium, which is generally immobile in plants, this allows it to extend out to every tip of the growing bud, which is necessary because calcium's primary role in a plant is production of cell walls. So with boron making it more mobile, the plant's growth should improve. Now, crab meal. A lot of people are wondering why crab meal. Well, this is just ground up crab shells, and the main component in crab shells is chitin. Chitin, however you want to pronounce it. And that relates to the trichoderma, because trichoderma is very fond of eating chitin-based things, including fungus, because fungus cell walls are also made of chitin. Now, in order to do that, trichoderma produces an enzyme called chitinase. And chitinase is a fun little enzyme chemical that has a fun little reaction when exposed to plants. Plants react to it with an immune response. I believe it is the ISR response, the induced systemic reaction. Basically, you combine a food source with a positive organism at the root base, and it will create an abundance of chitinase, and the plant will react in a positive way, bolstering its natural immune system. Now this is basically just a little bit of liquid kelp, a little bit of apple cider vinegar to acidify, because our water here has got loads of calcium carbonate in it. pH is out at 8 on a regular. And then a bit of molasses to help feed basically just give a little boost to both the plant because of the sucrose within the molasses, and the ecto and endo mycorrhizal to help them colonize. Now what we have here is our mulch on top, which is going to help hold in moisture and shield the soil, because you get a good beating sun and that top inch of soil can become nearly sterilized. One of our secret ingredients here, this is an extract compost from my Terra Preta pile, or I guess in Korean natural farming it would be an IMO 5. It is a well mature, you can't quite see it, but there's biochar in here. So basically, oh, there's some biochar. Basically we're gonna work that in, soak it in with this, and then top dress with that. And here we go. Now the reason I'm wearing gloves now, well, I should have been wearing gloves before, because that resin is it's nature's super glue, so it's pretty nasty if it gets on you. And I got a big old glob of it on my phone, so that's fantastic. But just working it in a little bit, nothing fancy. The soil's a little compact here, but the wood chips will help with that. Mix that all in. And now we are supplementing some natural fungus in the forms of the ectorrhizal and etc. But the biology that's in the Terra Preta fungus is absolutely incredible and will do good things for this soil. The more positive organisms we can have, the better, because it will outcompete the bad ones. Now, one of the tricks with the trichoderma specifically is the chitinase it produces. The reaction you get out of the plant is it can actually produce its own chitinase that prevents, or at least deters, more fungal infections in the future. So that's the kind of, I guess, the Cliff Notes version of why we want it. So now we're gonna water them in. Now I don't typically do any biological amendments with these type of sprayers, because of the amount of pressure you're putting into them and the way that their spray nozzle works. Most mycorrhizal specifically, any fungal forms, are not going to survive the spraying process. Some very small bacteria and archaea might, but you need a good profile of multiple species, an entire microenvironment. So you need archaea, bacteria, you need protozoa, large amoebas, etc. So that is why I don't use this for bioamendments. Compost tea, stuff like that, I don't use it. I have to kind of find a lighter sprayer for that, a more specialized one. But this, if this was later in the year, I could actually spray this right on the leaves, because it does work as a foliar. There is research out there that states that basically there's symbiotic organisms similar to mycorrhiza that live on the leaf surface and can actually metabolize, well, dust for lack of a better term, but debris that gets on the surface, and exchange it with plant cellular tissue in order, just like mycorrhiza, the plant will trade sugars, lipids, etc. So alright, I'm going to finish up with the spray in this, because it's not exactly good content unless I keep going on a long biochemistry lecture here. And then I'll put on the top dressing and we'll see what it looks like. Alright, now we are done. Last thing to do is basically just keep monitoring the tree. Now, anybody's got any questions on this? This is mixed. It's mostly pine, but there's some hardwood mixed in here. Now, anybody that is concerned about the wood chips, oh, it's pine, it's full of acid. Well, first of all, that's all pine resin on there, so clearly I'm not concerned about that. Pine will degrade a little bit faster than hardwood, which is, in this case, what I want. I want it to compost down and help feed the soil, because you feed the soil, you feed the tree. The other thing is, obviously, it's going to hold in moisture, which is going to help basically the soil life. Because you let that soil dry out, the plant will be fine, but the soil bacteria that we're trying to foster will not. And other folks have said things like, oh, it'll suck nitrogen. Yes and no, that's not really how chemistry works. Yes, it will pull some nitrogen from the surrounding millimeter of space. Meaning, yes, it'll draw a little bit of nitrogen out of the soil. But you know what? That's a stable nitrogen that's in the soil. You know what's a more freely available form of nitrogen that these things use when they decompose? The atmospheric nitrogen. And folks say it'll suck nitrogen like it's a bad thing. Well, it doesn't bind it up permanently. It will absorb nitrogen during the degradation and decomposition process, but it will quickly release it right thereafter, and it becomes a store of nitrogen. So on a much larger scale, yes, this will absorb nitrogen from mostly the air, and then it will release it in a stable form in the soil. So yeah, mulch is a much more positive thing than, well, some naysayers have opinions on. So I always use it. All right, and that's pretty much it. And well, Duke is inspecting our work, and I believe he approves. Or he's just benignly going away. Anyway, this project is, I'm calling it complete. Okay, we're about a month on from all the work we did with this tree, and it's looking like it appreciated the effort. It's definitely healthy and stronger. Still got a ways to go and getting it to stand upright. I've already done my first adjustment here. I'm pretty much doing it the first of every month. Alright, let's see here. Oh yeah, that resin hardened up real good and sealed. It tends to look like this when it's all the volatiles have vaporized out. It crystallizes, so it turns this whitish color.